Hello everybody and welcome. My name is Mr. Cantor and this is Modeling with Mr. Cantor. Now today we're going to be looking at Explore Part B. Please pause this video, read the story to yourself, and then we will read it together. Alright, welcome back. The story reads, here is the data set from an earlier lesson showing how long it takes for Diego to walk to school in minutes over 5 days. The mean number of minutes is 11. We can see here that the data is 12, 7, 13, 9, and 14. So they want us to represent Diego's data on a dot plot. Mark the location of the mean with a triangle. Please pause this video and attempt to do this yourself. Then unpause the video and check, does your dot plot match the one that we have here for you? Alright, welcome back. We're going to start making a dot plot by creating a number line. Our number line is going to range from 0 to 30. Your number line does not need to range from 0 to 30, but make sure that it does include the smallest and the largest values from this specific data. The smallest value here is 7, and the largest value here is 14. So just make sure that your dot plot covers those values. Now the first data point here is 12. So we're going to put a dot for where there is a 12. The second data point here is 7. So we're going to put a dot on top of the 7. We have 13, so let's get a dot on top of 13. We have a 9, let's put a dot on top of the 9. And we have a 14, so we're going to put a dot on the 14. Excellent work. Now, they're telling us to mark the location of the mean with a triangle. Before we do that, please pause this video and let us know, what does that even mean? Alright, welcome back. If you said the mean refers to the average number of minutes that Diego spent walking to school, which in this case is 11 minutes, then you are correct. So basically we need to look at our dot plot, find the number 11, and they want us to place a triangle there. And so here is our triangle. Good work. So if your dot plot looks like this one, then you are correct. Good job. Alright, so with that said, let's move on to the next part. We're going to look at Explore Part C. Now, before we jump in and start looking at Explore Part C, I want you to take a minute, pause this video, read the information provided to you, and then we will do it together. Alright, welcome back. Let's see what we have here. The mean can also be seen as a measure of center that balances the points in a data set. If we find the distance between every point and the mean, add the distances on each side of the mean and compare the two sums, we can see this balancing. They're saying record the distance between each point and 11 and its location relative to 11. So we're going to do this one at a time. In the middle here, where it says distance from 11, this part of the table, I want you to pause the video and figure out, depending on the time in minutes that we have over here on the left, we want to figure out what are this data's distance from 11. So go ahead, please pause this video and let me know what you think, and then we will do it together. Alright, welcome back. The first time in minutes is 12. We want to know what is that number's distance from 11. So therefore, we will have to take 12, subtract 11 from it, and we will see that that time in minutes has a difference of 1. Therefore, the distance from 12 to 11 is 1 unit. Good job. So let's take a look at the next number. The next number is 7. So we're going to have to do 11 minus 7 and get 4. One of the things that you might have noticed is that in the first example, we put 12 first, but in the second example, we put 11 first. And that is because we are referring to distance. When we refer to distance, we do not want a negative distance because that does not make any sense. Distance can never be negative. Distance is always positive. So please keep that in mind when you're trying to figure out the distance of your data relative to your mean, which in this case is an average of 11. Okay, with that said, let's keep moving. Time in minutes, 13. So we're going to start with 13 minus 11, which is 2. We have 9, which means we're going to have to start with 11 first. So we have 11 minus 9, which is 2. Now we have 14, so we're going to start with 14 minus 11, and we get 3. So these are the distances that you should have gotten. 1, 4, 2, 2, and 3. Good work. Now with that said, we're going to move to the next section of the table, which says left or right of 11. What I want you to do is to please pause this video, look at the time in minutes, and figure out, is this distance to the left or to the right of 11 on a number line. So please pause this video, fill in the rest of this table, and then we will do it together. All right, welcome back. 12. 12 happens to be to the right of 11 on a number line, and if this is what you said, then you are correct. 7 happens to be to the left of 11 on the number line, so if this is what you said, you are correct. 13 is to the right of 11, 9 is to the left of 11, and 14 is to the right of 11. Good work. So if you got right, left, right, then you are correct. Good job. So with this information finally filled out, we could begin to look at part B. Part B says sum of distances left of 11. So what I want you to do is to please pause this video. Look at all the times in the table the word left pops up and find the corresponding distance to the word left, and then we're going to find the sum. So please pause this video and let me know what you get. All right, welcome back. If you said the sum of distances left of 11 is 4 plus 2, which equals 6, because we have left here and we have left here, this left corresponds to number 4, this left corresponds to number 2, so therefore if you add 4 plus 2, you will get 6. All right, so with that said, let's take a look. What about the sum of distances right of 11? Please pause this video, look at all the times the word right pops up in the table, and then find the corresponding distances to those rights and find their sum. All right, welcome back. So we have right here, which corresponds to the number 1. We have right here, which corresponds to the number 2. We have right here, which corresponds to the number 3. So if we add 1 plus 2 plus 3, we will also get 6. So what do you notice about the two sums? Please pause the video and let me know. All right, welcome back. If you said you noticed that the left and right sums are equal, you are correct. And this is because the mean can also be seen as a measure of center that balances the points in a data set. In other words, the sum to the left and the sum to the right of our average or mean should be equal if we're looking for the distance from the mean to all of our data. Good job, everybody. Ladies and gentlemen, my name is Mr. Cantor. Thank you so much for watching this video. I hope it was helpful to you. I will see you in the next one. Take care for now.